On Friday, you're going to be taking test 12 for me. So today and tomorrow, we're going to go over our different review questions. So in your packet this week, you should have received your review list. Go ahead and take that out for me, and you can take some notes and some examples. As of course, this again is an open note and open book test that you'll be taking for me on Friday. You can see the lesson numbers that we're going to see on our test on Friday. Let's go ahead and begin with the information from lesson 69. One of the items that we learned about in lesson 69 with regard to our complex numbers was how to find their absolute value. Remember, absolute value is distance from zero, and in order to find that absolute value, we used the following formula. It was the square root of a squared plus b squared. The a was just the regular constant or the real part of your number, and then the b was the imaginary number that you had. So I did 3 squared plus negative 6 squared. 3 squared gave me 9, negative 6 squared was 36, 9 plus 36 was 45. When we did these absolute value questions before, and I would like you to do the same thing on the test, we did not give our answer as a decimal because we want the exact distance. But what I have here is a square root that does simplify. If we factor tree 45, that would turn into 3 times 3 times 5. I have my group of 2 that can move out to the front, and my final answer would be 3 square root 5. So watch out for that on the test, that you're able to factor tree and pull things out to the front as necessary in your question. You will have 2 at those kind of problems where you're going to find the absolute value of a complex number. The next section that you're going to face on your test is with your multiplication problems. You'll have 2 different kind of multiplication questions. Let's work through each one. We have negative 4i times 7 plus 3i. Well, what do I do with something that's right in front of a parenthesis? We need to distribute. So I did negative 4i times 7, which is negative 28i. I did negative 4i times positive 3i, which is negative 12i squared. Well, the directions as well will say, don't forget to simplify your answer. What does that mean? How do I simplify in this question? We know that we're not allowed to leave any exponent on the letter I. So notice in this question, we have an I squared. What is I squared equal to? It is negative 1. So now I have negative 28i. That first I is okay because it doesn't have an exponent written on it. And I switched out the I squared with a negative 1. Again, that doesn't mean minus 1. That means times negative 1 because it's right next to that 12 that we have in the question. When I do that multiplication, negative 12 times negative 1 gives me positive 12. So I have negative 28i plus 12, and just the proper way to write that final answer in complex number puts the real number first of the 12 and then the I part right behind it. It is okay if you leave it in the format of the line before with the negative 28i plus 12. I will accept that, but the best answer would be the last answer there in the complex format with the 12 and then the minus 28i behind that. The other kind of multiplication question that we talked about from lesson 69 looked like this kind where we had to use our FOIL method to help us on the multiplication. Well, what is FOIL? We're going to multiply the first terms together. So 5 times 6 gave me 30. Then the outside, 5 times negative 2i is negative 10i. The inside, 4i times 6 is 24i. And then the last terms, 4i times negative 2i is negative 8i squared. Just like the last question, we have a higher exponent of I that we need to replace. I squared is equal to negative 1. When I multiply that out, I came up with 30 minus 10i plus 24i plus 8. So I waited to put my like terms together until I've completely replaced the higher powers of I in the question. Now, which terms can I put together? We have the 2 constants of the 30 and the 8. So 30 plus 8 would give me 38. And then the 2 imaginary parts, negative 10i plus 24i is positive 14i. The number is in that correct complex number format of the real part first and then the imaginary part behind it. So I would go ahead and leave my answer just like that. So that will be questions 3 and 4 with the 2 kinds of multiplication problems that you will face on Friday. The last thing, or actually 2 more things from lesson 69, the next thing that we talked about was the higher powers of I even past the I squared. So if you had a question like this, I to the 30th, well, what was the correct process to simplify with those higher powers of I? The first thing that we did was we divided out the groups of 4. The reason we were dividing by 4 in our question is because I to the 4th is equal to 1. You're really just dividing out a bunch of 1s in the question, which doesn't change the problem. So how many times does 4 go into 30? It goes in 7 times. Well, 7 times 4 is 28, which leaves me with 2 left over. So the remainder in my question is 2. What do I do with that remainder? That's the new exponent that I have on the question. So I to the 30th is the exact same thing as I squared. Well, what is I squared? We just saw that on the last 2 questions. I squared is -1. Let's do one more. This one has the number in the front, and they're also going to do the higher power of I. So let's begin with that exponent, 19. What do we do with that exponent? We're going to divide it by 4. So how many times does 4 evenly go into 19? It goes 4 times. 4 times 4 is 16. So if I started with 19, I took 16 out, I have 3 left over. What do I do with that remainder, the new exponent that I have in the question? Now, don't forget about that -4 that's still in the front. A couple of you did that on your quiz. You just simplified the I part and forgot about the number that was in the front. So I still have my -4, and now here's my new power of I to the 3rd. Well, what is I to the 3rd? By definition, it is -I. So -4 times -I is +4I, and that would be my final answer in this question. So it's perfectly fine for me just to have a regular I in the question. If we end up with an I squared, that gets replaced with -1. If I end up with an I to the 3rd, that replaces with -I. And if we had an I to the 4th, then that would just replace with 1 in our question. The last thing that you will see from our lesson 69 material is your 2 kind of division questions on number 7 and 8. Well, notice on this question with the division, there are not 2 pieces in the denominator separated by a plus or a minus sign. So how did we go about simplifying on this question? All that we had to do was multiply by the I. Remember when we first learned about I back in class, we learned that I was equal to the square root of -1. Well, how have we always got square roots out of the denominator? We multiplied by the exact same square root. The number 3 is not the issue in the denominator. It is only the letter I. So I'm multiplying both the top and bottom of my fraction by I. When I do that, I have 12I in the numerator, and 3I times I is 3I squared in the denominator. Well, what is I squared? We know that's -1. So 3 times -1 makes -3 in the denominator. We've done the main goal, that we've removed the I from the denominator. That's what it meant to simplify or to rationalize. But we have one more step on this question. We're able to reduce that fraction. 12 divided by -3 is -4. So my final answer would be -4I. So if I just have the letter I or even a number in the I, no plus or minus, then just multiply by the letter I in the question. The other kind of division problem that we saw looks like this one, where there is either a plus or minus in the denominator. So we have 8 over 3 plus 2I. Because of the plus sign that we have in the denominator, we no longer can just multiply by I. So what did we do in this situation where there was 2 terms down there? We multiplied by something that was called the conjugate. The conjugate was the exact same 2 terms, you only switched out the sign in the middle. So I'm multiplying both the numerator and denominator of my fraction by 3 minus 2I. Make sure you're doing the same thing to both parts of your fraction. Like we saw during class, if it's helpful, go ahead and put these all inside parentheses with those double terms, and that might help you out with this multiplication. So go ahead and begin in the numerator. We have 8 times the 3 minus 2I. Well, how do I multiply a number times a parenthesis? We just need to distribute. 8 times 3 would be 24, and 8 times -2I is -16I. In the denominator, if you remember with the conjugate, you could actually do that shortcut. We knew we could do the shortcut with just the first and the last terms because the outer and the inner terms are going to be the exact same pieces, but with different signs. If I have the exact same thing, but one positive and one negative, they would cancel each other out. So what do I have for the first terms? 3 times 3, which would make a 9. And then 2i times negative 2i is negative 4i squared. Once again, we have some things that we can replace there. So I squared is negative 1. So in the denominator, negative 4 times negative 1 was positive 4. So I fixed that in my denominator. The numerator is still the same. There's nothing that I can do with that right now. So 24 minus 16i, and the denominator, I've changed that to 9 plus 4. Again, I can't do anything with the numerator. Those are not like terms because one has I, one doesn't. So in the denominator, 9 plus 4 is 13. Don't forget, you're working with fractions. Can I reduce this fraction? Well, let's look at the three numbers that we have. We have a 24, a 16, and a 13. 24, 16, and 13 do not all have something in common. Therefore, I cannot reduce, and that would be my final answer on this question. So those will be your problems from questions 1 through 8 that we talked about back in lesson 69. Let's go ahead and move into lesson 71 now. This will come from questions 9 through 11, where we learned about the law of sines. Remember, in the law of sines, you have an angle that is matched up with its opposite side, and you're going to use different ratios to help you as you're solving in the question. Go ahead and copy down this triangle, and let's walk through how to correctly solve this. This would be like the same 3 questions that you'll do for me on the test in the same order. So just make sure you're following the order that I have the questions on the test. If I'm going to correctly solve that triangle, what did that mean? I'm looking for all of the missing pieces. Currently, there is one missing angle and there are 2 missing sides. So what's the first thing I'm going to have you find in this picture? It is the one missing angle. In order to find that one missing angle, we know that we have a triangle. So how many degrees are in a triangle? 180 degrees. So in order to find the n that is at the top, I took 180 and I subtracted out the 2 that were given to us in the picture of the 65 and the 74. When I correctly subtracted those, I know that angle n is equal to 41 degrees. So you would do the same process when it comes to question 9. You're going to have 2 of the angles in the picture. Your job is to find the third one, so subtract from 180 degrees. I'm going to go ahead and put that information in my picture now. And the reason that I want to do that is, remember, in the law of sines, you have to have a complete ratio. You had to have an angle that matched up with its opposite side. You have that information now in the picture that we have located the angle n. That's why I had to do that angle first. So let's say the next thing I want to find in my problem is side m. Well, if I'm going to use side m, then I have to go about using the law of sines. So with the law of sines, we have the sine of our angle, which was 65. That's something else that a couple of you did on your quiz. You're putting the side lengths next to the word sine, not the angle. It's always the sine or cosine of an angle, not of a side length. So when I was looking for side m, which angle was opposite that? The 65. So I have sine 65 over its matching side of m equals, and then here's the complete ratio that I have, the angle of 41 degrees, so sine 41 over its opposite side, 14. To solve when 2 fractions are equal, just like we did in lesson 71, we're going to cross multiply. So m sine 41 equals 14 times the sine of 65. Just like we did in that lesson, I do not want you using your calculator until the very final step in the question. I don't want to round too soon because then I'm going to get too far away from the correct final solution. To finish getting the m by itself, I'm going to divide over the sine of 41. Again, don't do anything without your calculator yet. Just write down what you're going to do. Now that we have the letter m all by itself, now we can finally go onto our calculator, and I came up with that m is 19.34. Make sure that you are doing this cross multiplication correctly. Some of you had it backwards. You were multiplying like the m times the sine of 65 and the 14 times the sine of 41. Don't multiply going up. You multiply going across for cross multiplication in your question. Well, so far we found angle n. We found side m. What's the last thing that we need to find? It is side p. In order to find side p, again, we have to use the law of sines. What angle corresponds with side p? It is the angle of 74. So I said the sine of 74 over side P, and then once again, there's my complete ratio, the angle 41 degrees, so sine 41 over its side length of 14. Let's go ahead and cross multiply and see what we come up with here. We have P sine 41 equals 14 sine 74. Divide over that sine 41 to get the letter P all by itself. And now again, we can type it in our calculator, and I came up with that P is 20.51. We had talked about a different situation in the law of sines where you could get what was called that ambiguous answer. Those kind of questions will not appear on your test. It will be this situation where you have two angles, so there's only one possibility for that third angle in the picture, and then you can use the law of sines to help you find the two missing sides that you would have. Let's go ahead and just finish up with a couple more questions this morning. These will come out of lesson 72, where we are talking about some properties of logarithms. You will have on questions 12 and 13 problems that look like this. The process that we had gone through in lesson 72 in these kind of questions was we were looking for matching bases. If the bases matched, we were able to ignore them, and the answer was just the other part of the question. Notice in this problem, we have over here a base of 2 on the exponent. We have a base of 2 right here on the logarithm, so we can ignore those pieces. And what are we left with? The 8x plus 9. So no work that we have to do there. We just need to recognize that we have matching bases. If we have matching bases, we ignore them, and the answer is the other part that you have in the question. So two problems like that, I think one example is sufficient because you just need to ignore a certain piece and then give the other part as your final answer. The last thing out of lesson 72 that I'm going to have you answer with regard to the law or log questions was this kind of problem where we had to evaluate a logarithm that wasn't just one of our main logarithms like the log or the ln. So how do I go about evaluating the log base 4 of 10? Well, in lesson 72, we had learned about what was called the change of base formula. The change of base formula allowed you to take the original question and split it up into a fraction question. As you split it up into the fraction question, you were either able to use the log, that was called our common logarithm, or the ln, which was used our natural logarithm. I went ahead and used the log just because that's what this question started with. That doesn't have to be what you do. You could get the same answer either way. The change of base formula, all that it did was you put that log, you put the log into both your numerator and denominator of your fraction. The order of the numbers mattered as we put them into the fraction now. The 10 is going to be the last part of your question. It's called the number part of your logarithm. So the last number goes into the numerator. The base is what went into the denominator of your question. So we're going to do on our calculator log base 10 divided by log base 4, or just log 10 divided by log 4, and that gave me our final answer of 1.66. Again, I tried that on my calculator the other day with the ln, and I got the exact same answer. So you could do ln 10 divided by ln 4, and you would also get 1.66. Again, just remember, the number at the end goes into the numerator. The base goes into the denominator. So maybe it would help you. The base goes into like the basement, which is underneath the house. So you would need to put it underneath your fraction. We will pick up with questions 16 through 25 during our review tomorrow, but that will give you some things already to look over and prepare for our test on Friday.